Today we are going to see about EC2 instances, especially placement groups within EC2 instances. And we also will see about the purchase options Amazon provides us for cost management of EC2 instances. So let us start with placement groups. You have been looking at it for some time now. Placement groups are nothing but if you have a group of servers and you want those group of servers to talk to each other with low latency and very high bandwidth, then you create something called network placement groups and put all your servers in your network placement groups. So as the image that you see here shows, all the servers are able to reach each other and all of them will have a 10 Gbps network connection. To achieve this, there are some minimum conditions. For example, one of the conditions is not all instance types are supported. Only the latest variants of the instance generations are supported, and instance types have to be having the network bandwidth is also a minimum requirement. For example, when you choose an instance type, it comes with a predefined network bandwidth of 10 Gbps or 20 Gbps or 5 Gbps. So only those instances which have a minimum of 10 Gbps or are having higher bandwidth can be added to a placement group. And another limitation is placement groups cannot span across availability zones. So if you want to have a low latency, high bandwidth requirement, you need to have two placement groups, one for each availability zone. And likewise, you cannot move an instance into a placement group. For example, you started an instance and you find that that instance also needs to be a placement inside a placement group. You cannot attach it or move it inside the placement group. You need to create an AMI and then start it inside the placement group. So there are some limitations, but the important thing that needs to be understood is placement groups will have a very low latency and they will have a very high bandwidth between them if appropriately configured with the right instances. And this is very important when you have a large organization, when a lot of servers or your application servers or internal website are going to be served to your internal employees only, then it might be efficient to put them all inside a placement group. So there is a very nice documentation Amazon has provided in the placement on the topic of placement group. So if you go to this URL that that I shared with you, and you should be able to see that now anytime. It details more about the placement group and also the limitations as well. There we go. So this is the Amazon documentation for placement group, and as you can see here, it is a low latency, high speed, high packet per second network performance for your placement group. And if you just scroll down a little bit, you can find out the placement group limitations as well. And there are a lot of limitations there. You should be very careful on setting up your placement group, or before starting to decide starting to create your placement group, you need to go over the limitations and design it appropriately. And when it comes to design the placement groups, there is not much to do other than going to the console and clicking on the placement group. Let us look at that now. If I have already logged into my EC2 dashboard, let me just open that. And when you see on the left hand side, there is under network and security, you have an option called placement group. If you click on that, it opens the EC2 dashboard for placement groups, and all you have to do is click on this placement group and type in the name that you want. This name has to be unique within your account. You cannot have multiple placement groups with the same name. So this is all there it is to do there, and whenever you are starting an instance, you just have to ensure that you are choosing this group placement group option when you're starting an instance. So automatically, if it is a C2 or C4 or M4 instance, and if they are inside a placement group, all of them will have a bandwidth of 10 Gbps or 20 Gbps. And the interesting restriction is if two servers are having different bandwidth, the maximum throughput that you will achieve is the slower of the two. servers. Say for example, server A is having 10 Gbps and server B is having 20 Gbps. The maximum throughput that you will achieve is 10 Gbps. And you should also configure the applications to talk to each other through their IP4 network. That is a private IP, not the public IP. If you are allowing them to talk to them in the public IP, the bandwidth might come down to 5 Gbps. All of these things that I'm saying are all listed in the limitations that you find it in the public page, and go over that, make yourself familiar with some of those things, and it is helpful for designing your infrastructure. So the next thing that we are going to look at today is EC2 cost optimization. Here we are going to see what are the things that we can do to optimize the cost of our EC2 instances. Whether we can buy different types of instances, or we can pre-book our instances, or shut down our instances when not in need. We'll see look at all those options one by one. So the first thing when we are talking about cost optimization is instance selection. The type of instances that you choose for your servers is going to decide the amount of charges that you are going to incur. So there are plenty of methods available in the market, plenty of methods used by different enterprises. The most common one is a simple flowchart. The flowchart is something like a type of applications that you run. What is your network bandwidth requirement? What is your performance requirement? Then you finally decide on your instance selection. Then just by looking only at your resource type, then brute forcing. Brute forcing is keep running your instances on different types of servers and try to find out what is the best instance type that works for you. So when it comes to flowchart, let us look at it in detail. So here's a sample example of the flowchart that sometimes gets used. You start at the beginning, you say that I need an instance, and what is the most constraining resource in your instance? Is it storage that is most constraining, or is it the performance or CPU performance or the GPU performance, or is it the memory or CPU performance? So based on that, then you go ahead and choose the appropriate instance type for you. For example, if storage is the constraint for you, is it a throughput optimized instance, or is it going to be a high IOPS requirement for your instance? If it is GPU, do you need more than one GPU, that is graphical performance, say for example video streaming or video processing or a real-time video or live casting or anything like that? Then you are going to need multiple GPUs so that you can process your videos in real time without much latency. So if you are going to be in memory, then how much memory you need? Are you going to be talking about a relational database, or are you going to have a very high spiky workload? So those kind of things you need to decide. And are you going to be a CPU intensive machine? Then you go ahead and choose a C4, or if you don't have C4, which is enough memory and enough CPU, you just go and choose a T2 micro. The reason T2 micro is given when you don't know is T2 has something called a burst capability. That means if you're not using the T2 instance, your CPU credits are all allocated, and it is like a bank. So whenever you suddenly need more CPU, you can go ahead and use the maximum capability that is available in your allocated limit. So you can burst through the CPU limit more than the average that is allocated to you, because it is getting accumulated slowly, and once the accumulation is having a good amount of credits in your account, you can burst your credit and go ahead and use more than your average credit limit. So this is a simple flowchart. Your organization might use a different thing, or you can come up with something better also, but it serves as a good guide when you're stuck when you're trying to choose an instance. So let's go ahead and see what other types of instance selection is there. So the next one is by resource. This is also similar to the flowchart, but you start looking hard at the resource type only. Say for example, CPU, disk, or network, and then if it is a disk, consider the caching and consider the memory optimized. You look more deeper into the type of resources that you're running rather than the constraints that is caused by the resource, and then you choose your appropriate instance types. Again, this will need talking to your application teams or your customers or business owners who are using the application, trying to model the application with them, and then trying to find out what is the resources required for those instances, and then going ahead and setting up the appropriate instance. And finally is the brute force. What happens is here is you run your instance on a particular instance type, that is run your resource on a particular instance type, run some load test, find out the load test parameters, and then find out the throughput parameters and see whether it is acceptable or not. If it is not having acceptable latency, then start it with another instance and then do all the tests again. And most importantly, what you're trying to do here is you're going to try to calculate your price and your performance. Remember, we are doing a cost optimization exercise. So you need to find out what is the price I am paying and what is the performance I am getting. And ultimately, if you're doing multiple instances, then you will put a chart something like this. This is my throughput here, and then this is the performance I'm getting, and this is the latency I'm getting. So as your throughput increases, your latency also, the latency decreases, the average latency, the response time, in other words, increases, and you finally end up in a situation where it is having unacceptable performance, and there is some headroom for you. This is a sweet spot that you want to hit, where your throughput and your response time is optimized, and it is very less. And you have a little bit of headroom to play around, where you can increase your throughput little bit without increasing your latency. So this is typically how brute force chart looks like. You can come up with your own, but it is a good talking point or a thinking point when you're doing a brute force method of selection. So finally, the type of purchases that you can make itself is split into 3 to 4 categories actually. This is a limited selection that is displayed here. The first is on-demand instances. If you remember when we were talking about, or if you have already discussed about EC2, whenever you go to a Amazon dashboard and start an instance, it is called an on-demand instance because you are not paying for it before, or you are not reserving it for yourself, and you are not bidding for the price. There is a predefined price given to you, and you are purchasing it by the hour. That means that you can stop it at any hour, and then you will be charged only for the number of hours that you are running. So that is on-demand instances for you. On contrast to that, you have something called reserved instances. When we are talking about reserved instances, you can buy them in advance. That is, you can buy them in 1 year reserved instances, or 3 year reserved instances, or 5 years. And the cost of the reserved instances goes down significantly, and you can get up to 75% discount when compared to on-demand instances. To give you an example, say you have decided to run your workload or your application for a minimum of 2 to 3 years, then it makes ideal sense to buy it for, or reserve it for 2 years, and then run on demand for the next half a year, so that your cost is going to come down significantly, and you can manage the instances more efficiently there. Because reserved instances means the capacity is reserved there and the performance is expectant. That means that you know that exactly this much performance I'm going to get from my reserved instances. And the final group of purchase options, not the final, the other one that you're going to see is spot instances. It's a very interesting concept Amazon has brought up, because spot instances are nothing but people giving up their extra capacity for a chargeable rate. So think of all the customers in Amazon having some extra capacity, and they want to make use of that extra capacity. Then they go ahead and release that extra capacity for spot instances, and Amazon sets up an auction, and whoever is bidding more money for that extra capacity will be given the spot instances. So in other words, you can bid as low as possible for spot instances and buy some compute capacity, and there are no upfront commitment, and the hourly rates are usually lower than the on-demand rate, because if it is more than the on-demand, people will go on buy the on-demand instances itself. They won't buy the spot instances. So usually the rate is always lower than the on-demand instance, and since there is always a bidding, if anybody is going to bid marginally more than you, the instances will be reallocated to that highest bidder, and you will be given 1 minute notice so that you can save all your data and then you can release that instance. Even if you're not releasing that instance, Amazon will remove it from your account. So when you're using spot instances, there is no guarantee that instances will be in your account. They will be released whenever there is a bidder who is paying more than yours. So that is one disadvantage of spot instances, but it is a very nice way to run big data clusters or EMR clusters based on spot instances, because your applications can be fault tolerant in that case, and you can also reduce the cost of running your big data clusters. So big data clusters are a very big use case for spot instances, and you should remember that. So this is another simple flowchart that helps you to choose what is the type of instances that you need to use. For example, you are a free tier, that is when you start your account and you do your POCs and you get started. And once you get started, you can go for on-demand instances. The on-demand instances are very good for spiky workloads or to define your needs. For example, to identify more about your application and then understand what is the exact instance type that you need, whether you need it for 1 year or you are going to need it for a very short amount of time, or your application is insensitive to workloads or instances disappearing. For example, if you know that your master data is somewhere like in a big data cluster and you're just copying some data to process, then you can go for spot instances. But if you are going to know that you are going to run your instances for a certain period of time, that is a committed period of time, let us say 1 year or 3 years or 5 years, then it makes it ideal use case for reserved instances. And if you're having a time sensitive workload or time insensitive workload or transient workloads, then spot instances are your best friends to reduce your cost. And remember that there are a lot of multiple automated algorithms available in the market for doing your bidding, so that you keep your instances at any cost. So there are those kind of third-party services are also available. They keep on bidding and ensure that the compute capacity that you bought in spot always remains with you, so that you can keep on doing your work and maintaining your workload as well. And these algorithms are smart enough to adjust to the fluctuating prices based on the demand and supply, and they constantly try to achieve a lower cost of ownership when compared to an on-demand instance. So when you compare to on-demand, spot achieves to be tries to be lower, and if your algorithm is smart enough, you will definitely be having a lower cost. And the final group is a dedicated instance. This is especially useful when we are talking about a compliance workload. For example, there are certain regulations that allows you or requires you to run it in a dedicated instance, meaning the hardware is dedicated to you. As you can see here, the hardware dedicated to a single customer. It is not shared by multiple customers, and you have the entire capacity of that dedicated workload allocated to you. So if you have a very sensitive workload and you don't want that to go offline or shared with the multiple people due to compliance reasons or sensitivity reasons, then you buy a dedicated instance, and the cost for that is marginally higher compared to the other services Amazon offers. So these are all the different purchase options that you get when you are talking about Amazon EC2 instances. So these are the different ways that you can remember. You can see the on-demand is it is looking at the whole data in terms of time perspective. The on-demand comes it by the hour, whereas a reserved instances you are buying it in 1 year terms or 3 year terms, and always there is a discount available if you are booking it in advance, whether it is servers or your ticket in any restaurant as well. Or flight tickets, if you book it in advance, you get a discount. Likewise, Amazon also gives you a discount if you do that. And there is something called a very specific interesting instances called scheduled instances. That means that they are available for a specific period of time. Say for example, morning 8 to evening 5, you can book it for that period of time also. And this recurring schedules, you can do it for a minimum tier of 1 year term. So you can reduce your cost by buying scheduled instances. Instead of having a whole time reserved instance, you can buy a scheduled instance. So the instance appears in your account as stopped state in the morning time or evening time that you have chosen, and then you can start running your workload based on that. Then you have your spot instances. This is bidding on your unused capacity, and if you're and you they will be available as long as your bid is above the spot price. If your bid is below the spot price, somebody will be taking over it, and you will lose the instance capacity. And the next one is dedicated instances. This is a single tenant hardware, that is everything is dedicated to you and nobody else is sharing it with you. And again, the dedicated host, the entire hardware, that is not only the server, that is the blade, the entire hardware itself, the entire frame itself is dedicated to you in this case. So instead of buying few dedicated instances, you can buy dedicated hosts also, and then you configure it, the entire host itself as one instance or multiple instances as you see fit. Again, cost is the difference. If you're very much particular about sharing the servers with multiple tenants, then you go for a dedicated host itself. So these are all things that you discuss with your client and then choose the appropriate one for your client. So basically you go from the left to right here. You start an instance, then you fine tune it based on trusted advisor or based on your performance monitoring tools, and then you start scaling it with auto scaling or other scaling options that you get. Always start small, because the smaller the size gives you greater granularity in scaling, and then you can scale it to bigger instances. So start it, fine tune it, and then scale it. That is the logic when you're trying to do a production level scaling. And this is the most important thing you need to remember. Purchase your reserved instances after the application has been fine tuned and the utilization patterns are established. Don't go ahead and start buying reserved instances because you are going to run it for 3 years. Because when you are buying to reserved instances, you are going to choose an instance type as well. If you buy a T2 micro, or say not T2 micro, let us say M4, which is a general purpose one, and you find that CPU is a constraint, and then you should have bought C4 instances for 2 years, then that is going to incur additional cost. So fine tune your application, understand your patterns, and then see what is the most constraining resource in your application, and then buy the appropriate reserved instances. And this is how a typical workload should look like. Let us say this is a typical pattern that you have in your application, and let us, I'm just going to put a graph on top of it. I'm just going to mimic the workload pattern, and assuming this graph is how your workload peak load utilization looks like, and you have an average utilization throughout the day for 2 instances, then they go ahead and book a heavy resource utilization. As you can see here, heavy utilization, book ahead an RI for that. And you see that at around 6 p.m. your workload is having a spike. Then you go ahead and start a medium utilization, that is you book ahead for medium utilization RI for another level. And likewise, you go ahead and book a light utilization RI. When I say RI, that we are talking about reserved instances. And finally, at morning 11 o'clock to afternoon 3 o'clock, there is a spike in workload. Then you go ahead and book your on-demand instances, start them on demand. So this way you are having a different cost utilization pattern here. So you are offloading some of your costs to reserved instances, and when there's a peak demand, you are going to have an on-demand instances. So by having a different layers of instances or different types of instances to meet your workload demand patterns, then you can go ahead and reduce your cost even more effectively. So this is one thing that you need to talk to your client, and then decide what is the type of workload that they are having, what is going to be the workload profile. If they don't know the workload profile, then you need to do some performance testing and understand the workload profile to understand when is the peak load happening, when is the minimum load happening, and then go ahead and reserve your instances. There's finally something more, a snapshot of all the best practices. When we talk about EC2, always assign permissions to EC2 instances, that is your instance, your snapshots, your volumes, so that only the appropriate people have access to those EC2 resources. And when you're talking about the IAM policies for EC2 actions, create fine-grained policies. Do not use a star because it gives all the permissions, whether you want them to reboot the instance or you want to just monitor the instance. For example, you have an L1 team and you want them to monitor whether your instances are up and available, assuming you have not done any CloudWatch or you have not any alarms, but you have a team who wants to do it manually. Then you don't want to give EC2 actions to terminate or stop those instances. You just want them to have a read-only access to EC2 actions. So create a fine-grained policy so that they will be having only limited access. And finally, use the tagging because tagging can help you to take backups and snapshots. There is a fantastic video in our channel. You can go ahead and watch it on how to use tagging and Lambda to create snapshots and backups. And you depend upon the tagging whether it is a production or if it is an Drupal or if it is a WebSphere application or WebLogic application, the backup schedule might differ, or backup schedule might happen more often, or it might happen less frequently as well. So based on tags, you can configure how the backup should happen, and tags can also overlay the cost structure as well. Say for example, you have two tags, one is production and another one is a department. So based on this tagging, your cost can be calculated, saying production in HR department is having this much cost, whereas in dev team or apps team is having this much of production cost. So it might help in optimizing the cost as well. And require dedicated tenancy as a condition, because dedicated tenancy has an additional cost to it. So you don't have to go ahead and start with dedicated tenancy for everybody. Choose it appropriately and choose it wisely. Do not allow everybody to go ahead and start requesting for a dedicated tenancy. So